types of hybridization. Second type is sp2 hybridization. Here 1s and 2p orbitals hybridized and form 3 sp2 hybrid orbitals. These are having equal energies and these are oriented towards the three corners of an equilateral triangle. And the angle, that is bond angle, will be 120 degree. Okay, and the structure is trigonal planar. Okay, let us take one example in the case of BCl3. Here boron is the central atom. Its ground state configuration is 1s2, 2s2, 2px1, 2py0, 2pz0. Okay, and boron in the excited state, one electron from S will shift towards 2py. So 1s2, 2s1, 2px1, 2py1 and 2pz0. Okay, these valence orbitals, that is 1s and 2p orbitals hybridized and form 3 sp2 hybrid orbitals. Okay. And in the case of chlorine, it contains the valence orbital is in chlorine is p orbital. Okay. So these each sp2 hybrid orbitals overlap with the p orbital of chlorine atom. Okay, and form 3 BCl sigma bonds, which are oriented at the corners of an equilateral triangle like this. So 3 sp2 hybrid orbitals. Okay, these overlap with the p orbitals of chlorine atom, and the structure will be like this, and structure is trigonal planar. Okay, structure is trigonal planar and bond angle is 120 degree. So this will be the structure of BCl3. Okay. Second example, C2h4 Ethylene. So this contains two carbon atom and each carbon atom is sp2 hybridized. So carbon, ground state, 1s2, 2s2, 2px1, 2py1, 2pz0. Next, in the excited state, one electron from 2s shifts to 2pz. Okay, 1s2, 2s1, x1, y1, 2pz. Okay, this will be the excited state electronic configuration. So this carbon is sp2 hybridized. So 1s and 2p orbitals hybridized and form 3 sp2 hybrid orbitals. Okay. This half-filled atomic orbital will not take part in hybridization, so it remains as unhybridized. Okay. Then, in the case of each carbon atom, 3 sp2 hybrid orbitals of equal energy will be there. These are oriented towards an angle of 120 degree. Okay. Next, each carbon atom sp2 hybrid orbital overlap axially and form cc sigma bond. Okay, like this. And the other two sp2 hybrid orbitals overlap with hydrogen atom each and form CH sigma bond. Okay. Now, next there is an unhybridized p orbital in each carbon atom. This will be oriented at an angle of 90 degree with this plane, with these sp2 hybrid orbitals. Okay. So, these two unhybridized orbitals overlap sidewise. Okay, and form a pi bond. So there will be an electron cloud will be obtained. Equal electron cloud is obtained above and below the plane of this sp2 hybrid orbitals. Okay, so thus a pi bond is obtained. So this is the structure, and the structure of the molecule is planar. Okay, so this C double bond, C denotes it contains one CC sigma bond and one CC pi bond. Okay, and now CH bond is the bond length is 108 pm. Okay, and HCH bond angle is 117.6 degree, and the CCH bond, this bond angle is 121 degree. So this will be the structure of ethylene, and the geometry is planar. Okay. Sp hybridization. This involves the hybridization of one s and one p orbital and form two sp hybrid orbitals. Okay, these two are having equivalent energies, and these are oriented at an angle of 180 degree. Okay, and in the case of sp, s character is 50% and p character is 50%. Okay, let us take an example, BeCl2. Here the central atom is beryllium. Its electronic configuration is 1s2, 2s2, 2px0, 2py0, 2pz0. There is no electron. It is vacant. These p orbitals are vacant. Okay, this is the ground state configuration. Now in the excited state, what will happen? One electron from s to s will shift to 2px. Okay, so electronic configuration will be like this. Okay, now these two, one s and one p orbital hybridized and form two sp hybrid orbitals. Okay, so two sp hybrid orbitals are obtained. Okay, these are oriented at an angle. This is the structure of BeCl2 at an angle of 180 degrees. So the structure of the molecule is linear, and these two sp orbitals of beryllium, okay, overlap with p orbital, which is the valence shell of chlorine atom, overlap with p orbital of chlorine atom and form BeCl sigma bond at an angle of 180 degree. These two overlap in the two opposite directions and form 180 degree, and the compound is linear in shape. Okay. Second example of sp hybridization, C2h2 acetylene. It contains two carbon atoms, and these two carbon atoms are sp hybridized, and each carbon atom form two sp hybrid orbitals. Okay, so the electronic configuration of carbon in the ground state will be 1s2, 2s2, 2px1 and 2py1, then 2pz0. Okay, now in the excited state, one electron from 2s shifts to 2pz. Okay, excited. 1s2, 2s1, 2px1, 2py1 and 2pz. Okay, so it is sp hybridized. So 1s and 1p hybridized and form two sp hybrid orbitals. Okay, now these two will not take part in hybridization and form unhybridized orbitals. Okay, now this each carbon atom contain two sp hybridized orbitals. Okay, these one each will overlap axially. So one from one carbon atom and one from the other carbon atom, sp orbitals, sp hybrid orbitals overlap and form a cc sigma bond. Other sp orbital of each carbon atom overlap with 1s orbital of hydrogen atom and form ch sigma bond. Okay, now it contains two unhybridized p orbitals. Okay, these are perpendicular to the plane of sp hybrid orbitals. Okay, so these two are perpendicular to each other and they will overlap sidewise. Okay, sidewise, and form two p orbitals. So two cc pi bonds are obtained. Okay, so this will be the structure like this. So this triple bond represents one sigma bond, one cc sigma bond, and other two are pi bonds. Okay, now the acetylene molecule, this is the angle between them is 180 degrees. So bond angle is 180 and the molecule is linear in shape. Okay, this will be the structure of acetylene.